Okay, in this section, we're going to be talking about how probabilities are determined. What is a probability? Probability is the chance of something happening. You know, we hear it every day in things like a 50% chance of rain, or when someone says 8 out of 10 doctors say such and such. These are just different ways of talking about probability. Now, probability can be written several different ways. It can be written as a ratio, or it can be written as a fraction, a decimal, or even a percent. Generally, when we talk about probabilities, we talk about it using percentages. Things like a 30% chance of rain, or you have a 25% chance of, such and such happening. But when we write about probabilities, especially mathematically, then we usually write them as a decimal. Anyway, let me show you what I'm talking about here. Let's go back to this idea of 8 out of 10 doctors. So if I write that as a ratio, that would be written 8 colon 10, because that's how we write ratios. Now, this is not in the best form. If I were going to write this in the best form, I would write it in fully reduced form. So do you see that both of these have a 2 in common, so we can reduce them down by a factor of 2. So if I divide the 8 by 2, I get 4. And if I divide the 10 by 2, I get 5. So actually written as a ratio, 8 out of 10 doctors or whatever would be the ratio of 4 to 5. If I write that in fractional form, I would write it as 4 out of 5. That's what that fraction means. Now, as a decimal, I would need to go on my calculator and do this division, because remember, a fraction is nothing more than just a division problem. So if I did 4 divided by 5 on my calculator, I would get 0.80. So that is the decimal form. And then if you'll remember, to change things to a percent, we always move the decimal over 2 places. So as a percent, that would be 80%. Oops, percent. Almost spelled that incorrectly. So these are the different ways that we write about and talk about probabilities. Generally, when we're talking about them, we talk about the percent form, and when we write about them, we usually use the decimal form. But I wanted you to see also that even as a fraction or a ratio, that it does mean the exact same thing. Okay, let's talk about some vocabulary and kind of get into the idea of what probability is. Now, probability is the result of an experiment, some sort of an activity that the results that you can observe them and record them. I have a picture of a die, a six-sided die, and if I were to roll that die, then we would call that an experiment because I could observe, what the roll face up would be each time, and I could record that. The result of an experiment is called an outcome. So each time I rolled the die, and let's say it came up with, this 4 on the top, that would be called an outcome. So in fact, let me write that out. If I were to roll this die, then I could end up with a 1, a 2, a 3, a 4, a 5, or a 6. These would be considered different outcomes. Now, when I look at all of the possible outcomes together, we call that a sample space. So this would also be called a sample space. Together, it's a sample space. Individually, it would be considered an outcome. We call these possibility of all these outcomes, we call them events also. So that's another way of thinking about them. The biggest thing that I want you guys to keep into mind when we're talking about probability is this. The core basic of all probability is success over total possible. So, and we're going to talk about that, and we're going to do some experiments or some examples here in just a little bit also. All right, let's talk about a little bit of vocabulary. There is something that we call experimental probability and theoretical probability. And we're going to be talking about that, quite a bit, even in class as we're working some examples and some problems. That there is a difference between experimental and theoretical probability. Theoretical probability is determined by calculations, not by experimenting. So it's where we would actually look at what is possible, total, successes over total possible, but in the theoretical realm. Experimental or empirical probability is what is determined by observing an experiment. So, and we're going to, I know it's kind of hard at first because we haven't gotten into this yet, but let's look at a coin. If I were to toss a coin, the outcomes could either be heads or it could be tails. True? Okay. When I said that probability was total successes over total possible, number of successes over total possible, then let's say that I wanted to know what is the probability of getting a head when I roll this or flip this coin. Well, in flipping that coin, let me just write this out here. In flipping that coin, the number of successes would be 1, because if I flip a head, then I'm successful. If I flip a tail, then I'm not successful. So there's 1 total success out of 2 possibilities. It could be heads or it could be tails. So those are the total number of possibilities. So flipping a coin would be the probability would be 1/2 that would turn out to be a head. Now, that's what we call the theoretical probability because it's done by calculations. If I were to actually take a coin, though, and flip it, then I might get tails 2 or 3 times in a row. That's the experimental probability. So when we're actually performing the experiment, then we call that experimental probability as opposed to theoretical probability. Now, there is something called the law of large numbers, or Bernoulli's theorem, Bernoulli, and it says if an experiment is repeated a large number of times, the experimental or empirical probability of a particular outcome approaches a fixed number as the number of repetitions increases. Now, what this means is the law of large numbers says that if you were to do an experiment over and over and over and over again, like flipping that coin over and over and over and over again, then eventually the experimental probability would approach the theoretical probability. The number of times that you flipped the coin and got the head would be, approximately a half. Let's say if we were to flip the coin 50 times. Well, hopefully we'd be approaching 25 heads out of those 50 flips. If we were to do it 100 times, we would get even closer to 1/2. If we were to do it 1,000 times, we'd get much closer to 1/2. That's the law of large numbers. Okay, some more vocabulary that we're going to need in this section is equally likely. Equally likely is when an outcome is just as possible as another. For instance, heads or tails if we're tossing that coin. Mutually exclusive is when the possibility of one event does not affect another event. For instance, if I were to flip that coin 5 times, well, what it landed on the first time doesn't affect what it lands on the second time. That's a completely different event. It's a completely different outcome. Complementary events, this is something else we need to talk about. These are events that are exactly opposite of each other, and their probabilities always add up to be a 1. Now, those are indicated by if you call an event A, just some random thing A, then A with a bar over it is its complement. So that bar over the letter always represents complement. And they say the complement of this event is equal to 1 minus the probability of the event happening. The event plus its complement always have to add up to be 1. They're probabilities, I should say. Now, probability itself always goes from 0 to 1. Now, the probability, if you say the probability of something happening is 0, then that means that it's not going to happen. It's not possible at all. But if you've got a probability of 1, then that means that the event is absolutely certain. It's going to happen. If we look at these in percents, it would be saying 0% to 100%. So 0 would be 0%. And if they say there's 0% chance of it raining today, then you know it's not going to rain. But if they say there's 100% chance, well, that represents a decimal form of 1. The 100% chance of rain means we better bring our umbrella and raincoat because it's going to rain. Probability always falls on a scale somewhere between 0 and 1.